Here we're going to talk about solving trigonometric equations. And all we mean by trigonometric equation is an equation that involves trigonometric functions. So let's take an example. Let's solve, and the instructions say use n as an integer constant, and we'll see what that means in a moment. So here's our equation. It's 7 times sine x minus 3 is equal to sine x. So as a strategy, when we have only a single, that is one trigonometric function, what we're going to do is we're going to isolate it on one side of the equation. So let's first subtract sine x from both sides. So we're just trying to get the sine x on only one side of the equation. And that gives us 6 sine x minus 3 is equal to 0. So isolating the sine, we're going to add 3 to both sides. So 6 sine x is equal to 3. Divide both sides by 6. So we have sine x is equal to, it's going to be 3 over 6, which is 1/2. Okay, so what we're looking for are values of x, that is angles, such that sine of the angles is equal to 1/2. So over here, I'm thinking to myself, okay, when is sine equal to 1/2? Well, I know that there's the angle pi over 6, right? So I can write that in, pi over 6. I know that sine of pi over 6 is 1/2. And I also know that sine of 5 pi over 6 is 1/2 as well. So that would be right here, 5 pi over 6. But these aren't the only angles, and the reason is because, isn't it true, for example, that if you're here at this point, well, if you add 2 pi to this angle, where does that bring you? Well, if you add 2 pi, you go all the way around, and you're back to the same point. So clearly, sine of pi over 6 plus 2 pi is also equal to 1/2. Okay, now it's not just true for 2 pi, it's also true, for example, for like 4 pi. That is, if you're here and you go all the way around twice, that is sine of, if you take pi over 6 and you add 4 pi, you're at the same point. So clearly I'm adding multiples of 2 pi, right? So I'm adding 2 pi and then 4 pi and then 6 pi and 8 pi. So basically, I can add any multiple of 2 pi and get back to this point. Now, it's also true that you can subtract multiples of 2 pi, right? So you can subtract 1 2 pi and subtract 2 2 pi's and be back to the same point. So what we say is that we want not just this angle right here. We want this point, but not just that angle. We want any integer multiple of 2 pi, and we write that as follows: plus n times 2 pi, okay? And the n is an integer. And by an integer, remember, we mean the counting numbers, basically 1, 2, 3, 4, also including 0, and then the negatives of the counting numbers, like -5, -4, -3, and so on, okay? So you want any integer multiple multiplied by 2 pi plus that pi over 6. So our x is going to be, well, pi over 6 plus any multiple of 2 pi, right? Because that brings you back to the same point. Any integer multiple of 2 pi. Okay, and the same is true with 5 pi over 6. If you add 2 pi to that, clearly you're back at the same point. And if you subtract 2 pi, same thing. So it's going to be 5 pi over 6 plus an integer multiple of 2 pi. And we know that n is an integer, okay? We're using n as an integer constant. So this would be our solution, our set of solutions. Now, how many solutions are there? And the answer is there are infinite solutions, right? Because you can pick any integer you want, and for any integer, you're actually going to get 2 solutions, right? You're going to get one here, and you're going to get one there. Okay, let's take another one like that. All right, let's solve secant of x plus 2 is equal to 0. Well, once again, we have a single trigonometric function, so we want to isolate it. So we get secant of x is equal to -2. And secant is hard to deal with, so we often convert that to cosine. So cosine of x, well, it's the reciprocal of secant, right? So if I take the reciprocal of -2, I get -1/2. So I'm thinking to myself, okay, when is cosine equal to -1/2? Well, it's going to be when the x-coordinate is negative, right? So it's going to be there. It's also going to be the angle down here. So here's my first angle, like so, and then here's my second angle, like that. So this angle, of course, is 2 pi over 3. And this angle, right, all the way around, that's 4 pi over 3. And of course, you want more than just those angles, right? You can be at these points, but you can add 2 pi and go all the way around, and you can keep doing that for any integer multiple of 2 pi. So plus n 2 pi, and then likewise plus n 2 pi. Okay, so our solutions are x can be 2 pi over 3 plus n 2 pi, and then comma 4 pi over 3 plus n 2 pi, again yielding infinite solutions. Okay, after this we'll go ahead and solve trigonometric equations where it's not simply a single trigonometric function. Okay, until next time.